Welcome back. Hey, since we're kind of nearing the end of our time together here with Algebra 1, I just wanted to sing you a song. I don't know where this road is going to lead me. All I know is where I've been and what we've been through. Blah, 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 blah. I don't remember the rest of this boys men. Okay, well, that's enough of that. That's silly. And why am I wearing this glove? I don't know. It's getting awfully hot in here. Well, it's February 6th, or wherever you are, it's probably May or something like that. Or if you just joined us today and you'd like to hit the subscribe button and the like 50 times, then you can do that too. Okay, focus, Spence, focus. Right. Today we're going to be looking at graphing linear inequalities, which is one of my least favorite things to do, just letting you know. But nevertheless, it's really, really important, and you need to pay attention to blah, 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 blah. Okay, here we go. Instead of having an equal sign in here today, and if you have not yet, you're using Saxon, you need to go and do the Lab 9 graphing linear inequalities so you know how to access the right buttons. I'll do a little bit of camera on the calculator here in a little while. If you haven't done that, you should do that first. But what we have here, instead of an equal sign, is we got these darn inequality deals there. Greater than or equal to, less than equal to, greater than, less than. And when we were doing these types of things with number lines, we had things like open circles, if it was only these types of things. We would have filled in circles if it was these types of things. And then we would have arrows either going to the right if it was this type of thing, or arrows going to the left if it was these types of things. So you'd have open arrow going this way, open arrow going that way, filled in arrows, filled in circles with arrows. We had these possibilities. I want to try to relate what we're doing today to those things, except it's going to be two-dimensional today. Instead of filling circles in, we're going to take a line and either make it dashed to mean it goes up to but doesn't include, and if it's filled in, we'll have solid lines. Instead of instead of arrow to the right and arrow to the left, we're going to have shading that's above a line, or we're going to have shading that's below a line. That's our analogy for today. Dashed or solid lines and shading above and shading below. We'll get into the whole thing. I'll show you what that's going to look like on your calculator. Go back 10 seconds if you missed that, right? So we're going to get something like this right here. Y is greater than 2x plus 2. And what I want you to do first is just think that that's equals. Okay? Just think of it as equals. And graph it. So I'd go up to 2. It's my intersection there, y-intersect. And then the slope of 2, so I go 1 up, connect it. Okay. There we go. There's like a good approximation of if it was y equals. Okay. Now, two things now. I'm looking for a solution. My answer set is actually going to be a space rather than on a number line going one direction. It's going to be a space, two-dimensional space. And this is telling me I want any answer in here for y on the entire plane that has a value greater than 2x plus 2. The 2x plus 2 is this line right here. So the space that meets that requirement is all of this business above the line. Okay, shaded, shade around there. And then, but it doesn't include the line. It has to be greater than this line. So I'm going to do this thing here. I'm going to make my line hashed, dash mark. And that would be the graph to this equation. It's going to shade above the line because we're looking for y values that are greater than the value 2x plus 2. 2x plus 2 is represented by this line, and it does not include this line. It has to be greater than. It cannot also be equal to. If perchance it had that on it, well, then we would make this a solid line because this line is part of the solution set too. And what they'll do in the book is they'll say, here's my inequality, and maybe we'll treat it like this again, it's dashed. And they'll ask the question, maybe, is 0, 4 in the solution set? Is that a value that's in the shaded region? And so you'll go and you say, well, 0, 1, 2, 3, 4 is right there. Yes, it is. Yes, that is a solution, a potential solution to this set. It would satisfy that inequality. And I would double check this with the math, and I would say, when y is 4 and when x is 0, is this still true? Well, is 4 greater than 0 plus 2? Is 4 greater than 2? We'd say, yes, that is true. And so, yes, that is a solution to this particular inequality. Now, let me pick a different data value. Let's go with 2, 2, 3. And if I go on the chart, I go 1, 2, 1, 2, 3, that's over here. And we'd say, no, that's not in the shaded region. But what we will do is double check and say, well, because maybe I just didn't draw my picture very well. Is 3 greater than 2 times 2 plus 2? Well, that's 4 plus 2 is 6. And we'd say, no, no, it's not. 3 is not bigger than 6. Okay, so algebraically, you double check on that solution. Now, I've kind of gone a little fast and loose there for a couple minutes, but the question was, what is a solution to a linear inequality? And I just said a solution is going to be space in the shaded area on the plane. Not solutions, yes, solutions. And then we just have to worry about whether or not we're including the line or whether we're only including everything up to the line. And again, that's the difference between dashed line or solid line. And then also, if it's y is greater than, we're going to shade above. Or if y is less than or equal to, in this case, we're going to shade below. The only other cases that they're going to have is something like, when y is greater than 0, and then we just say, okay, what y values are greater than 0? We would say everything up here, like we have a flat line. Or what if we said x is greater than 2? Well, then we would have to go out to 1, 2, draw an x line and say anything greater than x being 2. X is 4, x is 7, x is 12. That would be that kind of condition. And here, if it's just greater than, I got to make it a dashed line. Okay? Dashed line, not equal to. Solid line, yes, it is also equal to. Shade below for less than, shade above for more than. Let me set up my calculator and I'll show you how to check these things visually and which buttons to push. And then if we want to check a point, how we can do that visually as well. Okay, still there? Hello? All right, so got my calculator here. I'm going to go to my y equals, and I've already typed in 2x plus 2. If you got your normal window, Zoom 6, then you get your basic line. Hello, boring line. All right, we don't want that. We want y is greater than. And so what we do is when we get here, you see how the cursor's on the equal sign? We're going to use our little left arrow, and it goes and it highlights that whole area over there. You can hit enter at the bottom. This pops up. I can choose my color. Maybe I want to go with magenta or green. I'm going to go back to red. I scroll down and I get to here, and I use my left and right arrows, and look what happens. I can change that thing to whatever inequality that I want. And so I'm going to go with this for starters. Y is greater than. And it shows me the style that it's going to use. You can see you got a little dotted line there and shading above. Of course, it also will have shading below. It'll have shading below with a dotted line. It'll have just a line. It'll show you exactly what it's going to do if you ever forget which kind of shading that's you want to accomplish. So we're looking for this. We go down to OK and graph. And instead of just a line, what do we get? We get shading. We get shading above a dotted line. It's a little bit hard to see on my screen, but there, that's a little bit better. Shading above a dotted line. And you just need to represent that on your graph paper or use a stampy stamp. And your solution set is all that region up there that has been shaded. Now, what does that look like if we change this a little bit? Let's go in and I'll use blue and I'm going to go with this. I should get a solid line this time. And the shading above and up to that line. There we go. It's a solid line this time and we get shading. If I want to do that kind of algebra check on a data point to see whether or not it's on there, I could just kind of use the scrolly button thing and scroll around until I get to the place that was in question. But I don't get it exactly in the spot. So what we can do is we can go second program. You hit the draw thing here, second draw. And I get this catalog of all things we can draw. I'm going to go over, use my right arrow to go to points. I'm going to turn a particular point on. Hit enter. And this comes up and says style. And I guess I can turn a point on by scrolling around. Let's take a negative. Let's go -3 and I don't know, 2. I guess I'm still scrolling around. Now I can hit enter and it puts a dot there. I can pick the style too. What do I want it to do? I want to make a big, yeah, I'll stick with that. There we go. If I go back to the home screen and I do second draw, I go to points, it'll pop up on the home screen like this, and I can type in whatever address I want to, like 0, 4. And then when I hit enter, it goes back to the graph and it will plot the point 0, 4. It's really hard to see on mine, but it's right up there. And it is in the shaded region, so I can verify that that is true. Okay, if I go back to the home screen and I go second draw, point on, and I pick the point 1, -2. I hit enter, it shows that point down there not being in the shaded region. Pretty much that's it. There's maybe one other thing that you could do, and that is if you have an x equals line, you're going to use your cursor and you're going to go up into the upper corner there to hit enter, and now we're going to try to graph x equals line. So let's try x is greater than 2, and we want it to graph that. It graphs my other line, and it's going to graph, well, I guess that's less than, isn't it? It'll double graph, it'll double shade some stuff on there for you. You should play around with that a little bit and see if you can like predict, yeah, it was less than, wasn't it? You can predict what it's going to do when you pick a particular type of shading. And just realize you always got that little button graph there to double check on what actually happens. I mean, the solution is the picture. So you've got that to your advantage. There it is, x being greater than 2. It's a dashed line at x equals 2 and everything shaded to the right. There you go. I think that's enough for that. If you've got questions on the last example, please bring that to class. I'd be happy to help you with that.